Sorry for the nasally voice and the sinus issues I'm having. Bear with me on that. Up to this point, we've covered the particles that are located in the nucleus. Those are protons and neutrons. At this point, we are going to step outside the nucleus and look at the outer stuff, the stuff going around the outside of the nucleus, and those are called electrons. This is 1.7 electrons. Watch out! Lightning is extremely dangerous. A single bolt of lightning can carry billions of volts of electricity. That is enough energy to light a 100-watt light bulb for 3 months. As impressive as it is, lightning is nothing more than a sudden flow of extremely tiny particles. What are the particles that flow in a lightning bolt? The answer is electrons. What are electrons? Electrons are one of 3 main types of particles that make up atoms. The other 2 types are protons and neutrons. Unlike protons and neutrons, which consist of smaller, simpler particles, electrons are fundamental particles that do not consist of smaller particles. The properties of electrons. Electrons are extremely small. The mass of an electron is only about 1/2000th the mass of a proton or neutron. So electrons contribute virtually nothing to the total mass of an atom. Electrons have an electrical charge of -1, which is equal but opposite to the charge of a proton, which is +1. All atoms have the same number of electrons as protons, so the positive and negative charges cancel out, making atoms electrically neutral. Where are electrons? Unlike protons and neutrons, which are located inside the nucleus at the center of the atom, electrons are found outside the nucleus. Because opposite electric charges attract each other, negative electrons are attracted to the positive nucleus. The force of attraction keeps electrons constantly moving through the otherwise empty space found around the nucleus. The figure shown below is a common way to represent the structure of an atom. It shows the electron as a particle orbiting the nucleus, similar to the way that planets orbit the sun. We see here the nucleus, which is composed of the neutrons and the protons. The electrons are going around in orbit. So this has 3 protons and 3 electrons. We can see that this first energy level or shell is holding 2 electrons, and the next one is holding 1. The electrons fill from the inside closest to the nucleus out. Right? This has 3 protons. This must be an atom of lithium if you're looking at your periodic table. What is your energy level? What's your energy level? Electrons are located at fixed distances from the nucleus called energy levels. You can see the first 3 energy levels in the figure below. The diagram also shows the maximum possible number of electrons at each energy level. We'll see. The electrons at lower energy levels, which are closer to the nucleus, have less energy. At the lowest energy level, which has the least energy, there is just 1 orbital, so the energy level, it has a maximum of 2 electrons. So you're going to notice them talking about orbitals. This is actually a term that we're not going to learn this year, but if you take chemistry later on, you'll learn a lot more about orbitals and how they affect the number of electrons and actually the probability of where those electrons would be. So this first energy level, this lighter, this green here, the second level green, there's the nucleus, the dark one, and this one right here is the first energy level. It holds 2 electrons. And only when a lower energy level is full, picking back up at the second bullet point, only when a lower energy level is full are electrons added to the next higher energy level. Electrons at higher energy levels, which are further from the nucleus, have more energy. They also have a greater possible number of electrons for reasons you may explore in high school. Electrons at the outermost energy level of an atom are called valence electrons. They determine many of the properties of an element. That's because these electrons are involved in chemical reactions with other atoms. Atoms may share or transfer valence electrons. Shared electrons bind atoms together to form chemical compounds. This term here, valence electrons, is very important. You might click on it to learn more about it. It's just basically the electrons in the outermost shell. So there might be lots of shells underneath here, a lot of shells underneath here, but the electrons in this outer shell are really important when it comes to figuring out how the element or atom will bond and react with other elements and atoms. So the first energy level holds 2 electrons. The second energy level holds 8 electrons. The third energy level holds a total of 18 electrons. It's a little more complicated as far as how many it actually holds and when they get filled up. So we really won't talk too much about elements that are greater that hold electrons greater than this for this year. So, question. If an atom has 12 electrons, how will they be distributed in energy levels? So if we're looking at our periodic table, we can see an atom that has 12 electrons. That looks like it's going to be magnesium. We'll have 2 here in the first level, and 8 here, that's a total of 10, and 2 in the outer shell. So we have 2, 8, 2. So the answer, the atom will have 2 electrons in the first, 8 in the second energy level, and 2 in the third. Sometimes an electron jumps from one energy level to another. How do you think this happens? Answer, to change energy levels, an electron must either gain or lose energy. That's because electrons at higher energy levels have more energy than electrons at lower energy levels. So when an item is heated, thermal energy is added. We can actually elevate the electron level, and those electrons get excited and they move up energy levels. And when they fall back down, they're able to release light. So this is some of the things we can see whenever we burn certain items. They release light because those electrons are falling back down, and they release electromagnetic energy, light. In summary, electrons are one of the 3 main types of particles that make up the atom. They are extremely small and have an electric charge of -1. All atoms have the same number of electrons as protons. Negative electrons are attracted to the positive nucleus. This force of attraction keeps electrons constantly moving around the nucleus. The region where an electron is most likely to be found is called an orbital. We won't actually learn about that this year. Electrons are located at fixed distances from the nucleus, called energy levels. Electrons at lower energy levels have less energy than electrons at higher energy levels. And that wraps up 1.7